So on this solving one, you have two radicals. We want to isolate one of them. I'm just going to isolate this one here. So I'm going to subtract this over. So I have 7 times the square root of x plus 7 equals 30 minus the square root of x minus 5. So whichever one I isolated, Grace, will just cancel. So if I square both sides here, this 7 squared is going to be a 49. And the radical squared, the radical will just cancel, but it's a binomial, so keep it in parentheses because we will have to square, distribute that 49. The right-hand side, when I square it, though, that's a binomial, 30 minus something else. So I actually have to expand that and multiply it by itself. So while I'm right here, I'm going to distribute my 49. And Lord knows I don't know what 7 times 49 is. I should. 343. Yes. Now on this side, to Grace's question, are the radicals just going to cancel? 30 times 30 is 900. 30 times negative square root of x minus 5 is negative 30 square root of x minus 5. Like that's a whole number times a radical, so the whole number just kind of sits out in front. On my next distribution, another 30 times negative square root of x minus 5 is going to make another minus 30 times the square root of x minus 5. And then on your last one, so to your point, Grace, no, those radicals did not cancel. But this last multiplication, negative square root of x minus 5 times negative square root of x minus 5, that will. It'll be negative, and then the square roots cancel each other, and it just leaves you with x minus 5. Oh, it's not. It's positive. Thank you. Negative times negative is positive. So now from here, I still have radicals, and I can combine. I've got negative 30 of these and negative 30 of those, which is going to make negative 60 of them. So I'm going to move over here and just copy down the left-hand side. On the right-hand side, I have some combining of like terms. I have a 900 and a plus that, though, because it's a plus sign, those parentheses don't really matter, so plus a negative 5. 900 combined with a negative 5 is going to make 895. So that covers my numbers. I have this random plus x, and then negative 30 and negative 30 of those radicals is negative 60 of those radicals. And so while one of the radicals canceled, both of them did not. So I essentially restart the whole process. Isolate the radical, square both sides. So I'm going to subtract this 895 over. I'm going to subtract this x over. So now I only have 48 x's minus 552 equals negative 60 root x minus 5. Now, I don't think anybody wants to divide away that negative 60. It won't be pretty on the other side. This is a terribly ugly problem. The whole squaring of the binomial with a radical involved is not uncommon. Just the size of these numbers is rather annoying, but we'll fight through it. So I'm going to square both sides. Oh boy, 48 squared. Holy golly. 2304 x squared. And then I'm foiling in my head. 552 times 48, and I'm going to have 2 of those. Just follow me with these huge numbers. Sorry. And then 552 times 552 is plus 304704. Gosh. We're going to cheat with this quadratic because no one's factoring that. And then on the right side, a negative squared is going to become a positive. A 60 squared is going to become a 3600. And then the radical is just going to cancel. Are you seeing this for a minute as a binomial and thinking about foiling? But it's not. It's a monomial. Negative 60 with radical something, even though what is under the radical is a binomial, negative 60 times the radical is just a one term. So the negative 60 gets multiplied by the negative 60 to get you the 3600, and the radical gets multiplied by the radical to give you just x minus 5. So that's going to be 3600x minus 18,000. And then it's a quadratic. So I'm going to get everything equal to 0. I'm going to subtract the 3600x over to the left, add the 18,000 over to the left, and then my disaster of a quadratic. No, 304,000. 30,000 would be way too small. You got to go to a 300. And then I would just graph this and cheat to find my answers. So I'm just going to type this in. Which is not just like, oh yeah, from here on out it'll be easy. Because I got to make sure my window is appropriate so I actually see something. Because I don't think on the negative 10 to 10 window, I'm very confident that anything would show up. Nothing. So I would maybe go out negative 100 to 100. I am just sort of blindly guessing right now on the window. What may actually be more appropriate, look at your table. Look at the size of the numbers we're dealing with. So you can look here and see how those y values are decreasing. They decreased for a little bit and then they went back up. Nine minus 5 is 4. Square root of 4 is 2. 9 plus 7 is 16. Square root of 16 is 4. Oh, it is 9. I'm sure we made a mistake with these massive numbers because that's clearly not the answer to our quadratic. So I'm not going to go through there and find it. We obviously did make a mistake. To the point I said earlier, solving the radicals with two radicals in there, that's expected. Huge of a numbers. I don't know why how this question originated. It looks like at some point I highlighted, maybe I just need to ditch this whole question and put a more appropriate one up there. I'll go back and see if I can find it, but the process is there. The isolating the radical, the squaring both sides, only to have to re-isolate the radical and square both sides. It's just these numbers are obnoxious. I apologize for those. Let Grace give you what you're looking for, though, with the how-to part of it. Good, sorry. Those are definitely the radical ones or the harder ones to begin with. Never mind huge numbers on top of it. But your other solving ones, number 1, that's not going to be so bad because there's only one radical in there. We're just going to subtract the x over and square both sides. It'll still be a quadratic. We'll still have to check both solutions. But it's not squaring a radical. Same thing here. Square both sides. It's not going to be a squaring of a binomial that contains a radical. So those are all of that type. The mixture of radical exponents type, number 1 falls into that category. Number 3 falls into that category. Number 4 falls into that category. Number 8 falls into that category. Number 9. Number 12. Oh, by the way, 11 was a solving one also. But let me just pick, I don't know, this one for fun. 12. All radicals and some exponents. Anytime there's a mixture, go to exponents. So this is going to become what? Grace O'Connor. What power? Emma O'Connor, sorry. I knew I had two Emmas. I sure did. Good. X to the 2/3. This one, TJ, what's the square root of x to the 5th going to turn into? 5/2. Good. And Jake McEwen, what's the 6th root of x going to turn into? There's no 2 there. This was a 2 because it was a square root. This is a 6th root. To the 1/6. Right? Because that's technically a 1. So the exponent on your x becomes the numerator. The index becomes your denominator. Okay? Now from here it's all exponent rules. So these two are going to be added. Now if you love getting common denominators, feel free. Most of you don't, so I'm just going to show you on the calculator and remind you, 2/3 plus 5/2 is going to give me a crazy decimal. Hit math and then enter for fraction, and it will turn that into 19/6 when I add those fractions. Over x to the 1/6. Now your dividing common bases, we subtract. 19/6 minus 1/6 should be better able to be done in your head. X to the 18/6. And then 18 divided by 6 is just a nice even whole number of 3. X to the 3rd. So that would be option 3. Yeah. So again, anytime you have that mixture, radicals, exponents, mixture, go to exponents. Follow all your exponent rules that you've known since you've been in Algebra 1. And then go back. So yeah, 9 is a radical within a radical. So if you kind of work on these from the inside out. So if I look at this inner one, that's the square root of x to the 3rd. So let's not even mind that 8th root for a second. What does the square root of x to the 3rd become, Grace? X to the 3/2. Very good. Now, the 8th root is the same as raising it to 1 power. The 8th root is the same as what power? One over 8. So, if it's just a root, then you just use a 1 as your exponent. And then the exponent rule is power to power, you multiply. 3/2 times 1/8 is 3/16. And that would be the answer in exponential form. If you want to go back to radical form, which this one says simplest radical form, it's the 16th root x cubed. Those are both simplest form, but one's exponential, one's radical. Okay, on something like 7, you guys, if you're asked for the domain, I would probably just graph it and look at the table. See what your x values do. Technically, by hand, you can only take the square root of something that's greater than or equal to 0. So whatever you're trying to take the square root of, make it greater than or equal to 0. You would subtract 2 from both sides and divide by 3. Because you know what? The table is only going to show you whole numbers. So you might get in the ballpark with the table and maybe be able to answer it, but you're only allowed to take the square root of a positive, so that just is where we set that piece greater than or equal to 0. So that's more of a graphing type question, as is number 6. See how they look at how they throw number 6 at you. They're testing transformations, but not in a way that the calculator would be helpful. They use A's and B's, not numbers. So if you're looking at this and you know that the parent graph looks like that, which you should, what one thing are you sure happened? What one transformation are you sure happened, Grace? It flipped upside down. It vertically flipped upside down, which would be a negative sign out in front, which 2 and 4 both have. So at least that's a process of elimination piece. Now, A and B are positive. We shifted left A units. And remember how that's always backwards. If you shifted left A, it's X plus A in parentheses. Makes it option 2. That was for you, so in a minute when I finish. Remind me. And then the only other one here that really didn't fit into any of those main categories, there are 12 questions. 10 of them are accounted for. Well, I will wake them up. There's 10 questions accounted for. We got 2 random ones. So here's something that might be a random one. Writing the inverse. That whole process, switch the x's and the y's, so x now equals y minus 3 cubed plus 1. Switch the x's and the y's and solve for y. So I'd have to subtract the 1 over. And how do you get rid of the third power? Cube root it. Right. To get rid of a square, you square root it. To get rid of a cube, you cube root it. So you would cube root this. So you'd have the cubed root of x minus 1 equals minus 3. And then just add 3 to both sides, and you're done. So your homework is the review sheet, yes, and just studying, okay? I gave you the breakdown. If you want to look at this again, it will be on the video. Drew, hold up. You have a little minute.